Hello students, myself Dr. Jyoti C.K., Assistant Professor, Department of Physics, title of the paper Mechanics and Properties of Matter. Today class we will be studying about the center of mass. What do you mean by the center of mass? It is the point where the entire mass of the particles are concentrated. A point where entire mass of the particle is concentrated, that we call it as a center of mass. We can see now here in the figure where is that center of mass. So let us consider now the inertial frame of reference where the Cartesian coordinate system x-axis, y-axis and a z-axis. O be the origin. Let us consider now there are n number of particles are there, whose masses are represented by the term m1, m2 up to mn. I will show here in the figure. These are the masses of the n number of particles. Like a m1 is the mass of the first particle, m2 be the mass of the another particle, m3 be the mass of the another third particle. So they are at the distance from the inertial frame of reference. How much the distance is that? From origin to m1 it is at the distance r1. From origin to m2 it is at the distance r2, and this is an r3 up to rn for a n number of particles. Here in this figure we can see now the capital M we have written here. Capital M means what here? This is the mass of the entire particle. Means the combination of m1 plus m2 plus m3 up to mn will give rise to the capital M. And where it is located? This point M means entire mass of the particle is located at the point C here. How much the distance is there? Capital RCM. RCM means R is the capital R is a distance. The combination of R1 plus R2, R3 up to Rn. So M1 plus M2 plus M3 is nothing but the capital M. R1 plus R2 plus R3 is nothing but the capital R. Cm, what it denotes here? Center of mass. Okay. So this is a capital M is an entire mass of the particle which is concentrated. That we call it as a center of mass here. Okay. So now we have to write the position vector of the center of mass. What is the position vector? As I told here, position vector is an RCM. How we will write the distance? That is a position vector for the center of mass here. M1 plus M2 plus M3 up to Mn into RCM, which is nothing but M1 into R1 plus M2 into R2 plus M3 into R3, so on up to how much? N number of particles like a Mn into Rn. So this you consider as equation number 1 here. But we know, already I have told you that M1 plus M2 plus M3 is nothing but the capital M. How? I will written here. M1 plus M2 up to Mn is nothing but summation of small m. And this summation of small m is nothing but the capital M here. Where this is the summation of small m is nothing but the capital M. So now this capital M is nothing but the total mass of the system. Total mass of the system. So the equation number 1 will changes now. How we will write the equation number 1? This M1 plus M2 plus M3 you will write it as a capital M, because I have written a summation of small m is nothing but the capital M. In this place just write a capital M. This is the RCM, which is equal to again this M1 plus M2 plus M3. These are nothing but the summation. You take it as a summation. So therefore summation of Mk and Rk. So now the equation 1 is now written in this form. Again here cross multiply here. I will show here now. This RCM is now equivalent to summation of Mk Rk, position vector, divided by the capital M. So this is an equation number 2 here. So this is the case for the n number of a particle. So now taking into this equation consideration, we can write it for the 2 number of a particle. That is a 2 particle system. How we will write now? That is the RCM, there is a position vector RCM is equal to, in place of Mk and Rk, you want to write it for the 2 particle system. That is a M1 R1 plus M2 R2, position vector divided by the capital M. So this is an equation number 3. Similarly, you can write it for the 3 particle system. How we will write the 3 particle system? Like a M1 R1 plus M2 R2 plus M3 R3 divided by capital M. So capital M is nothing but the combination of M1 plus M2 plus M3. Okay, so in this way we can write this. By considering this equation, we can write it for the many number, like in a 2 particle system we can write this equation. We can convert into the 3 particle system, even we can convert into the 4 particle system here. So in this way we can write for any number of a particle system. So till now we learnt about this center of mass. So next we will move to the motion of the center of mass. So here again consider the system with the n number of particles whose masses are m1, m2, m3 up to mn, and they are moving with the velocities like a v1, v2 up to vn with respect to what? With respect to the inertial frame of a reference here x, y, z. Now we are studying about the motion of the center of mass. Okay. So now capital M be the center of mass with the velocity capital V into Cm. What is the Cm? Denotes the center of mass. Capital V is the velocity of the entire, not an individual. So now the momentum. Now we have to write the momentum of the entire system. How we will write the momentum? What does the momentum says that? Momentum is nothing but the product of mass into the velocity. So now we will write now m1 into v1 plus m2 into v2 plus up to mn into vn here. So now the momentum of the center of mass. How we will write the momentum of the center of mass here? That is equivalent to capital M V into Cm. Capital V is nothing but the total velocity. I am telling here the total velocity. Combination of the V1, V2, V3. Okay. So this equation we have written it for momentum of the entire system we have written like a m1, v1 plus m2, v2. And this is the equation for the center of mass. There is a momentum of center of mass. There is a capital M, V, C, M. So now this becomes capital M, V, C, M is nothing but m1, v1 plus m2, v2 and so on up to mn into vn. So therefore what we can write here? VCM is nothing but it is equivalent to this equation. So combination. See previous I have shown there. M1 plus M2 plus M3 is nothing but summation of small m. So therefore written as a summation of small m. V1 plus V2 plus V3, that is a summation of Vk. That is a velocity. So divided by the m. So this gives a motion of the center of mass. Till now we learnt about the motion of the center of mass. So now next is the center of mass has a reference frame. So in this inertial frame of reference is remain fixed here with the center of mass of an isolated system. Then the center of mass is at a rest with respect to this frame. Means with respect to this frame means with an inertial frame of a reference. So in this case what happens here? In any inertial frame of reference here, the center of mass of an isolated system will move with the constant velocity. It is going to move with the constant velocity, means the velocity of the center of mass will remain in a 0. So therefore VCM is equal to 0. When the velocity is a 0, the momentum is also going to become a 0, because the momentum is nothing but the product of mass into the velocity. So therefore VCM is 0 and as well as PCM is also going to become a 0. So therefore this frame of reference, we call that one as a center of mass has a reference frame, or as the center of mass frame of a reference here. So now in the absence of external force, suppose you are not applying the external force here, so the total momentum is going to become a 0 here. Again the total momentum is going to become a 0. So this frame of reference is also called as a 0 momentum force here, because the P is a constant or else V is a constant. Both are constant here, or else both is a 0 here. So therefore sometimes this center of mass as a reference frame is also known as a 0 momentum force. That is in the case of absence of external force here. So the total momentum is going to become a 0. Hence the center of mass of the system is that point where the whole mass of the body is concentrated, is considered to be the concentrated, such that the total momentum of the system, of all the system, will be equivalent to the momentum of the masses which is considered to be concentrated at the center of a mass here. So today class we learnt about the center of a mass. So next class we continue with the another one. Okay.